The Mystery of the Human Miracle, 5 Modifications of Human Evolution. Hello, and welcome to my channel. Millions of years ago, they were able to walk upright, learn to use tools, know how to use fire, and are hardly different from today's human beings. However, why did these close relatives go extinct one by one? What is even more puzzling is why, exactly 70,000 years ago, when there were less than 1,000 of our ancestors left in a desperate situation, human beings suddenly ushered in an unprecedented awakening. From that point on, we went all the way to the top of the blue planet, defeating the stronger Neanderthals, conquering the oceans and ice sheets, and even triggering a planet-wide 6th extinction event. How did humans go from extinction to dominance? Was it a miracle of evolution, or was some unknown force behind it? Scientists have found that humans have experienced at least 5 life and death moments of desperation, and each time, we have turned a crisis into an opportunity. Is this evolutionary black swan event a coincidence, or does it hide deeper rules? This issue will tell us more. On the stage of the blue planet, there have been at least 10 kinds of close relatives of human beings. 4.4 million years ago, the first upright walking ancestors appeared on the scene, carefully foraging for food in the sparse forests and grasslands. 3.7 million years ago, the characters that anthropologists call southern apes began to learn how to use their hands, and the southern apes began to learn how to use their hands, and the southern apes began to learn how to use their hands. By 3.7 million years ago, the characters that anthropologists call southern apes began to learn to use natural tools, thus increasing the likelihood of survival. By 2.4 million years ago, their descendants had learned to make tools to break up hard food with stone tools, and by 1.8 million years ago, fire-savvy Homo sapiens pioneers were making the nights less long and dangerous. They were not weak, even far superior to our ancestors in many ways. But 70,000 years ago, a global catastrophe struck, a copycat mission that could have been triggered by a supervolcanic eruption or a dramatic change in the climate, causing the global environment to deteriorate dramatically. One by one, relatives who were as smart as we are, or even stronger, were eliminated. In the end, so few players survive that, according to genetic studies, there may be fewer than 1,000 adults left who can continue to reproduce. Imagine a tiny community struggling to survive in a blizzard, with most of the planet's creatures having opted out, while our ancestors stood up to the ultimatum of an extinction-level copy. If surviving 70,000 years ago was a miracle, the evolutionary process since then has been more like a system parameter modification. Scientists have discovered that in the tens of thousands of years since the end of the world, our ancestors have suddenly exploded into unimaginable creativity. Tools have become more accurate, fire has become more skillful, and the advent of language has made collaboration possible. Between 70,000 and 35,000 years ago, we were on our way to a true awakening. The price of this awakening was bloody, and 35,000 years ago, Neanderthals, a species stronger and better adapted to the cold than Homo sapiens, mysteriously dropped out of history. Evidence suggests that our ancestors may have been active cleaners. After that, the conquests continued on the voyage across the ice belts and into the Americas until, about 25,000 years ago, every continent of the blue planet became our territory. With this came a dramatic change in the ecology of the blue planet. Large animal populations rapidly disappeared in what historians call the 6th extinction. In this copy, which we led, 65% of the large mammal population left the planet forever. Does Planet Blue sense that its rules are being tampered with? If so, why hasn't it stopped us? It was these stages of awakening that brought us from the brink of extinction to the pinnacle of planetary domination. But the question remains, is this incredible outburst purely an evolutionary miracle, or is there an unseen hand behind it? In the evolutionary game of the Earth, time has always been the harshest judge. About 4.4 million years ago, a creature called the ancestral ape, Adi, entered the natural stage and became the starting point of human evolution. This creature may have looked ordinary, even less robust than today's chimpanzees, but it contained the seeds of the future evolution of mankind. Living in the sparse forests of East Africa, Audie was able to walk upright on two legs, a key feature of the game mechanic update. So why East Africa? Scientists believe that this land was the cradle of the human race, and that the key to this was the formation of the East African Rift Valley. About 5 million years ago, crustal movements tore the land apart, turning East Africa into a complex environment of wet forests and dry grasslands. Audie and his offspring were forced to survive in these very different ecosystems. This variety of environmental changes has forced them to try new ways of living, such as leaving the canopy and going to the ground to forage for food. Some scientists have suggested that Audie's ability to become a pioneer of upright walking was likely the result of a certain genetic mutation. This mutation made its pelvis more suited to walking upright rather than climbing trees. From an evolutionary perspective, the short-term cost of this change was enormous. Walking upright made Audie slower and more exposed to predators. However, it was this forced renewal that allowed them to evolve stronger survival strategies over time. What the planet may not have realized was that this small change would open a huge evolutionary door for the future. Unbeknownst to Audie, it had already taken the first step towards humanity. In the rules of the game, every increase in capability is often accompanied by new limitations. Walking upright, one of the earliest evolutionary advantages of mankind, became a costly system update. The most immediate advantage of walking upright was the freeing of the hands, a milestone in the history of human evolution. For example, the American anthropologist Mary Leakey found a set of fossilized footprints of ancient humans at the site of Rattali in Tanzania, which clearly show the characteristics of bipedal walking. Leakey's discovery not only confirmed that early humans had been able to walk upright, but also provided scientists with important evidence to study how this behavior influenced human evolution. In addition, walking upright left hands free, which allowed our ancestors to carry more food or make complex tools. Imagine an ancient human on a grassy plain millions of years ago cracking a nut with a rock and holding the freshly picked fruit in his hands, a direct result of freeing up his hands. Archaeologists such as Richard Lee have also pointed out in their studies of hunter-gatherer societies that there is an inextricable link between the use of hands and the increased ability to make tools. The evolution of these tools not only enhanced the efficiency of human access to food, but also played an important role in group collaboration. Another vivid example is how walking upright helped humans adapt more efficiently to hot environments. British biologist Peter Wheeler proposed the energy-saving heat dissipation hypothesis. He pointed out that, compared with quadrupedal walking, the upright posture dramatically reduces the amount of direct sunlight hitting the surface of the body, especially in the hot midday sun. This thermal advantage allowed early humans to operate in hot environments for long periods of time, while other predators often chose to avoid them because they could not withstand the heat. This difference in circadian rhythms gave humans a significant advantage when competing for resources. Walking upright was not only about survival, but also profoundly shaped the basic structure of human society. Imagine an early hunting scene. A group of ancestors could move faster and cooperate to round up prey by walking upright. Not only did they catch their prey, they freed up their hands to hold their young at the same time, giving the next generation a better chance of survival. This ability directly facilitated intergroup collaboration and even set the stage for complex social relationships. However, this advantage comes with significant risks. Walking upright narrows the pelvic structure, which directly affects how difficult it is for women to give birth. Compared to other primates, human labor was painful and dangerous, and premature birth became the norm. This evolutionary pressure forced early humans to take a more collaborative approach to childbearing and parenting, which indirectly gave rise to family values and group culture. Walking upright not only affected physical structure, but also profoundly changed social behavior. Research suggests that in the early stages of upright walking, the family unit emerged as a solution to child-rearing challenges. With mothers struggling to survive on their own, males were gradually bound to the family, taking on more protective and resource-providing responsibilities. This mechanism has been interpreted by some scientists as an early form of monogamy. Although not absolute, this model was indeed advantageous in early human populations. In the long history of the Earth, the evolution of human beings is like the seed, which needs both chance and the gift of the environment. And it was the invisible hand that drove all of this. Bipedalism alone was not enough to shape mankind. In this game of evolution, natural selection is both the player and the programmer. It is constantly modifying the genetic code to test which traits will help individuals survive and reproduce better. Scientists have found that about 10% of the human genome is associated with intelligence, language, and social behavior, and that the evolution of these traits has been driven in large part by environmental pressures. Climate fluctuations, for example, drove the need for early humans to develop new foraging strategies. Hunting created a need for teamwork, and these further shaped human sociality and intelligence. About 1.9 million years ago, Homo erectus made his appearance. Compared to Homo erectus had a taller stature, stronger limbs, and more complex behavioral patterns. Not only did they make more elaborate stone tools, but they also learned to utilize fire. Fire, not only as a tool for their cooking, but also as a weapon to repel predators. This discovery revolutionized their survival strategies. The able-bodied eventually outgrew their copy of evolution. They may have been eliminated because they were not competitive enough, or they failed to adapt to drastic changes in their natural environment. But Homo erectus inherited some of their genes and became the new protagonist, leading the human race from the African grasslands to the wider world. Have we ever wondered why human beings have become long-distance runners on the track of evolution? The answer begins with the endurance hunting of Homo erectus. Homo erectus was a natural long-distance runner. Their body shape was unique compared to other primates: long legs, short arms, large hips, and sweat glands that dissipated heat. These features gave them unrivaled endurance on the hot African savanna. Instead of relying on speed to catch up with their prey, they exhaust them through a sustained chase. This strategy, known as persistence hunting, is a form of hunting that requires a great deal of patience and teamwork. Scientists have discovered Ashari hand axes used by Homo erectus at archaeological sites in Kenya, tools that may have been used for skinning and cutting the flesh of prey. Research also suggests that Homo erectus may have been the first human to leave Africa. They traveled across the Middle East by running to Asia and even Europe. This feat not only reflects their physical superiority, but also shows their spirit of adventure. It can be said that Homo erectus is the first batch of explorers in human history. Their footprints paved the way for the later Homo sapiens, expanding the geographical map of mankind. Homo erectus is not the end of evolution, but the starting point for more versions. Over time, Homo erectus evolved different characteristics in different regions, forming several branches. The first to appear was Homo heidelbergensis. They are considered an important transitional stage between Homo erectus and Homo sapiens, and lived in Africa and Europe about 600,000 years ago. Homo heidelbergensis was taller and had a larger brain than Homo erectus. They were skilled hunters, making spears for throwing and using caves for shelter. The Neanderthals, Homo neanderthalensis, were a European upgrade of the Heidelbergers. Their story begins about 400,000 years ago in Europe and Western Asia. During the harsh Ice Age, the Neanderthals developed strong bodies and efficient survival strategies. They made fine tools, mastered the use of fire, and may have been among the first ancient humans to possess the ability to speak. Almost simultaneously with the Neanderthals were the Denisovans. Their sites are concentrated in Asia, and research on them continues to this day. By analyzing the DNA of the Denisovans, scientists have found that certain groups of modern humans, such as Australian Aborigines and New Guineans, are closely genetically related to them. Different branches of humanity did not develop in isolation from each other, but rather intersected and merged. For example, modern humans have about 1 to 2% Neanderthal genes in their DNA, showing intermarriage between the two. Similarly, certain groups of East Asians carry traces of Denisovans in their genes. About 200,000 years ago, Homo sapiens came onto the scene. Their tools were more refined, their language more sophisticated, and their society more tightly organized. But these abilities were not acquired overnight. They were gradually upgraded through thousands of generations of team copy challenges. In hunting, for example, large game often requires multiple individuals to work together, some to drive, some to ambush, and some to throw spears. Scientists have found that successful collective hunting is closely linked to improved language skills, as more complex tasks require more precise communication. This mechanism doesn't stop at hunting. From sharing food to nurturing offspring, humans learned to rely on each other. This behavior not only improved the chances of individual survival, but also accelerated cultural diffusion and social development. In modern society, despite technological advances, the spirit of teamwork remains an important engine of progress. Regarding the eventual disappearance of the Neanderthals about 40,000 years ago, scientists have put forward a variety of theories, and there are a lot of vivid research and discovery behind. For example, British archaeologist Chris Stringer points out that Neanderthals and Homo sapiens coexisted for thousands of years, but that Homo sapiens may have had a clear advantage in language, tool-making, and social organization skills. Such disparities gave Homo sapiens an advantage in the competition for resources, thus gradually displacing Neanderthals. In addition, by analyzing bones and tools from Neanderthal sites, researchers have found that they may have been more dependent on hunting large animals for their survival, and when climate change led to a decline in these animals, they may have been in a survival dilemma as a result. The Denisovans, on the other hand, are a more mysterious branch. Their existence was first confirmed in 2008 through genetic analysis of a finger bone from the Denisovan caves in Siberia. The study, led by Svante Pääbo, shocked the scientific community. Although the remains of the Denisovans are extremely rare, their genes have left traces in some modern populations. For example, the Denisovan genes carried in today's Tibetans and certain Southeast Asian groups are associated with high-altitude adaptations, suggesting that the Denisovans survived extreme environments and passed these adaptations onto their offspring. A vivid example of this is the Danny girl fossil that scientists discovered in the Denisovan caves in 2018. This is an individual of dual Neanderthal and Denisovan ancestry, with a Neanderthal mother and Denisovan father. This discovery not only gives scientists a deeper understanding of the interactions between the two species, but also reveals the complex social relationships that may have existed between ancient human populations. This cross-species hybridization also provides another explanation for the invisibility of the Denisovans. They did not disappear completely, but were integrated into other human populations through gene flow. In short, the seemingly different fates of the Neanderthals' extinction and the Denisovans' invisibility hide complex ecological and social dynamics behind them. These ancient human stories not only show us the cruel side of evolution, but also reveal the unexpected ancient heritage of modern human genes. The status of Heidelberg man as one of the direct ancestors of Homo sapiens is supported by numerous studies. John Hawks and others have argued that Heidelberg man was a key transitional species, retaining some of the characteristics of Homo erectus, but also possessing more advanced anatomical features such as a larger brain capacity and more refined tool-making abilities. Research suggests that they lived about 600,000 to 200,000 years ago and were a highly adaptable group of ancient humans. In Africa, parts of the Heidelberg man group are believed to be the starting point for the evolution of Homo sapiens. Archaeologist Christopher Scott discovered stone tools and decorative objects at Blombos Cave in South Africa that are about 75,000 years old, and these complex cultural manifestations may be traced back to the descendants of the Heidelbergers. Genetic studies also support the idea that there is a clear genetic link between modern African populations and these ancient ancestors, showing a continuum of evolution from Heidelberg man to Homo sapiens. On the other hand, those Heidelbergers who migrated to Europe gradually adapted to different climates and environments and eventually evolved into Neanderthals. A study at the Skaaningen site in Germany provides a vivid example of this transition. Here, archaeologists discovered wooden javelins, one of the artifacts of the Heidelbergers, about 300,000 years old. These javelins show a high level of design and manufacturing ability, suggesting that they had the skills to hunt large animals. However, over time, the cold ice ages forced them to develop unique survival strategies that evolved into Neanderthal traits. Interestingly, the gradual disappearance of the Heidelbergers in Europe was not simply a process of replacement. Recent genetic studies have shown that Heidelbergers may have mated with Neanderthals, and some of their genes were passed down through the Neanderthals. This not only reflects the complexity of human evolution, but also provides a vivid picture that ancient humans did not exist in isolation, but shaped today's human gene pool through constant intermingling and competition. Have you ever wondered if there is still some hidden connection between the human brain and the stomach? This connection has even influenced the fate of our species. The earliest primitive humans were not so different from other scavengers. They would venture out to scavenge for leftover bones and pieces of meat after large predators had left. By analyzing the cutting marks on early human tools, scientists discovered that they gradually mastered opening the marrow. This fat and calorie-rich food became a key resource for brain development. However, brain expansion is expensive. On the one hand, the brain accounts for about 20% of the body's energy consumption, which means that our distant ancestors had to seek out more energy-rich foods. On the other hand, the shortening of the intestine saves digestive energy, allowing more resources to be available to the brain. Studies have shown that gut length is closely related to dietary habits. Compared to similarly sized primates, humans have a short and efficient gut. This characteristic may be related to the fact that early humans began using fire and cooking food. Not only did fire change the structure of food, making it easier to digest, it may also have had a profound effect on social behavior. For example, sharing a meal around a campfire may have been one of the earliest social copies, facilitating the spread of language and culture. Natural selection is both the designer and the player in this evolutionary game that spans millions of years. But do we fully understand this invisible hand? Perhaps evolution itself is a game without fixed rules, full of randomness and creativity. Nowadays, technology has given us the ability to change the parameters. From gene editing to artificial intelligence, humans are redefining the rules of evolution. But does this mean that we have transcended natural selection? Or are we just starting another, more complex copy? There is no denying that humans have experienced upright walking, increases in brain size, the development of language and communication skills, changes in the use of fire and diet, and the emergence of modern Homo sapiens. As Stephen Hawking said, who are we? Where did we come from? Where are we going? These questions remain unanswered. The story of evolution continues, and the ultimate answer, perhaps hidden at some point in the future, is waiting to be discovered. Did you know? Humans have actually gone through at least 5 life-and-death desperate situations in the course of their evolution. The fact that we can sit here and talk today is, in the end, entirely due to the fact that our ancestors were smart enough, tough enough, and added a bit of luck. The first time, the Tuban super volcano eruption. Around 74,000 years ago, the volcano Tuban erupted in what is today Indonesia. The eruption was one of the most violent in the history of the planet, reportedly spewing ash that covered half the planet. This is not an exaggeration. Scientists have found that the eruption caused global temperatures to plummet into a volcanic winter. Temperatures in some areas dropped by more than 10 degrees Celsius, and the entire planet instantly turned into a cold ice cellar. What's worse, this environment was devastating to the survival of plants and animals, and humans were no exception. At that time, our ancestors lived mainly on hunter-gatherer, and after the food chain was disrupted, the pressure on their survival increased steeply. Some studies suggest that the human population may have dwindled to a few thousand at one point, as precarious as endangered animals are today. But the humans who survived may have found special survival strategies. For example, some may have gathered in areas close to the coastline and harvested marine resources for food, which allowed them to escape the famine. It is also said that the disaster instead accelerated the evolution of the human brain, because the harsher the environment, the more intelligence was needed to cope with it. The second, the African drought. Between about 120,000 and 70,000 years ago, Africa experienced a long period of drought. This period is known as the Great African Drought, and it was a very desperate time. Rivers dried up, lakes disappeared, and grasslands became deserts. The environment in which our ancestors lived deteriorated dramatically. Scientists found that only a few areas could still provide resources that barely sustained life, such as some lakes and coastal areas in eastern Africa. Human beings may be like a group of desperate travelers, huddled around these oases to survive. Interestingly, this drought also seems to have contributed to the beginning of human migration. Faced with a lack of resources, our ancestors had to explore new living space, and so embarked on a journey out of Africa. It can be said that this crisis not only did not lead to the extinction of the human race, but also became the starting point for our conquest of the world. The third, the Last Ice Age Summit. The last Ice Age peak happened around 20,000 years ago. Imagine a time when the Earth was covered by thick ice sheets, the sea level was more than 120 meters lower than today, and even the English Channel was land. Although the glaciers did not completely cover the human living area, the impact of the cold climate on life was absolutely devastating. By this time, the Neanderthals in Europe were extinct, and the challenge for Homo sapiens was to survive the ice. Hunting large animals became the main survival strategy, but that was no easy task. Huge animals like mammoths and Cape rhinoceros were both dangerous and rare, and failure to hunt could mean starvation for the whole family. To combat the cold, ancestors also invented new tools and techniques, such as making clothing from animal skins and building stronger shelters. Interestingly, the plight of the Ice Age seems to have made humans more cooperative and may have even led to more complex social structures and cultural exchanges. The fourth, the Black Death. Jumping ahead in time to the Middle Ages, from 1347 to 1351, a deadly plague broke out in Europe, the Black Death. The plague destroyed one-third to one-half of Europe's population and had far-reaching global consequences. The Black Death was a form of bubonic plague that spread so quickly that many people died within days of being infected. Medical treatment at the time was completely inadequate to deal with the disease, and people could only watch their friends and family die. The streets of the city were littered with corpses and social order nearly collapsed. While the death rate of the Black Death was horrific, it also changed the structure of society and the shape of the economy. The drastic reduction in the labor force allowed the survivors to improve their living conditions instead. Land was redistributed, wages were raised, and even technological advances were fostered. It can be said that although this disaster was heartbreaking, it also indirectly promoted the development of human society. The fifth, nuclear war crisis. Speaking of the most recent global life and death test, it was the nuclear war crisis during the Cold War. From the 1950s to the 1980s, the world was shrouded in the shadow of nuclear war. Once the confrontation between the US and the Soviet Union escalated into an all-out war, the planet could literally be reduced to rubble. The closest moment to nuclear war was the Cuban Missile Crisis in 1962. At that time, the Soviet Union deployed missiles in Cuba, and the United States reacted strongly when it found out that the two sides were at crossroads, and the whole world held its breath. In the end, it took a series of tense negotiations to defuse the crisis. This crisis made mankind realize that while technological advancement makes us powerful, it can also be a tool for destruction. Perhaps because of this, countries began to pay more attention to the control of nuclear weapons and signed a series of treaties to limit them. Today, we still live under the shadow of the nuclear threat, but at least it's a lot safer than it was during the Cold War. Well, that's it for this installment. Likes and comments welcome, and thanks for watching.